This video contains the solution for problem number 5 in the they're from the 2009 AP Calculus BC Free Response Questions, Form B. So we have a picture of a function that I'll refer back to here. This is the derivative of a function, so note that. And the original function f is twice differentiable, so we can do all the calculus we want on a domain a little bigger than this, including those little tails. And f of 1 equals 2, so that's an initial value they're giving us. This is the derivative. This is a point on the original function. The graph of f prime and the derivative here is what we're looking at. It crosses the x-axis where it looks like it does, and it has a horizontal tangent line where it looks like it does at 2. And then we have another function, g of x equals e to the f of x. We want an equation for the tangent line to the graph of g at x equals 1. Well, to write the equation for a tangent line, we need a point and a slope. So we need to know what is g of 1 and what is g prime of 1. This will be our point, and this will be our slope. Well, let's see. The g function, g of x, is equal to e to the f of x. So g of 1 would be e to the f of 1, and that's the one value that they gave us. F of 1 is 2. So g of 1 is equal to 2. So we have our point. The point that this goes through is the point 1 comma e squared. A derivative, since the g function is here, its derivative, g prime of x, well, the derivative of e to the whatever is e to the whatever. And that's not just an x, so times the derivative of what's inside. And so g prime of 1 would be equal to e to the f of 1, that's the 2 again, plus f prime of 1, and f prime of 1 is negative 4. That's a point that's marked on the graph there. So f prime of 1 is negative 4. So my slope is negative 4e squared. That's a little bit icky, so I'm going to go ahead and write my answer in point slope form. So that's y minus y is equal to m times x minus x. That's the y, that's the x, that's the m. There's my line. Part B. They would like us on this domain to find all values of x at which g has a local maximum, and then justify our answer. Well, let's see. G would have a local maximum, maxing out when it went from increasing to decreasing, or when g prime, in other words, goes from being positive to being negative. So let's see if we can set g prime equal to 0 and figure that out. We've got the g prime function. G prime of x is equal to e to the f of x times f prime of x. And I'd like to know where this is equal to 0. That would give me the critical points. Well, we've actually seen this kind of thing before. This, no matter what you raise e to, positive numbers, negative numbers, 0, fractions, whatever, this is always positive. E to the some power is always positive. So really, all we're looking at is this. So when is that equal to 0? That's equal to 0 at x is equal to negative 1 and negative 3. Oops, sorry, positive 3. Because after all, this is the f prime function we're looking at. So multiplying it by this would change the shape of it, but it's not going to change where it's positive and negative, and it's not going to change where it crosses 0. And likewise, if we want to know a maximum, that's when it goes from increasing to decreasing. And so this is where f prime is positive to negative, and it's the only place where it goes from being positive to negative. So the maximum on the g function is at negative 1. So max at x equals -1 because g prime of x has the same sign as f prime of x, and f prime of x goes from positive to negative at x equals -1. So that's our answer right there. Part C. The second derivative of the g function is this. They've actually gone ahead and done the derivative. We found the first derivative, but they're not going to let you miss this part by messing that up. So they're giving us this, and they want to know if it's positive, negative, or 0, and to justify our answer. So let's see. Leave that there so I don't have to recopy that. So g double prime of 1 would be equal to e to the f of 1, that's e squared from part A, and f prime of 1 squared plus f double prime of 1, and we're trying to figure out the sign of this. Well, this is always positive. F prime of 1, that's -4, so -4 squared is 16, plus f double prime of 1, let's see, what does it look like the concavity is here? It looks like it's going from being concave down, concave up, and oh, sorry. That was almost a rookie mistake. This is the derivative. So the second derivative at 1 is the slope of this. And that looks like it's a negative number. And is it as big as 16 here, this number squared? No, it is not. It looks like if this is 1, -4, that's a negative slope, but it's not bigger than 16. So there's 16 minus that negative number. This is positive. So I think f double prime of, are we supposed to be doing it a -1? Oh my goodness, and I did it at a 1. So let's fix that. So this, okay, this is still e to any power is still positive. Let's go back and fix these. Sorry about that. And let's see, f prime of -1, oh, that's 0, isn't it? That's so sorry about that. That's 0 squared, so it's going to depend on the sign of this. And then by the same reasoning here, this is a negative number, so that's a positive 0 minus a negative, so this is actually going to be a negative number. So f double prime, g double prime of -1 is less than 0. And this is our justification. We don't ever have to write any words about that. And the last part, part D, find the average rate of change of g prime, which is the derivative of g, over the interval from 1 to 3. Average rate of change is slope. So that would be what we're looking for, average rate of change of this. So that would be g prime of 3 minus g prime of 1 over 3 minus 1. It's the slope, right? Average rate of change of whatever is the slope of that whatever. So I need to find these values. Let's see, going back to what the g function is, g prime of 3, do I have g prime on here somewhere? I do. If you can see that, we have our g prime is right here. So g prime of 3 would be e to the f of 3 times f prime of 3, and it's using this, minus e to the f of 1 times f prime of 1, all over 3 minus 1 is 2. So let's see if we have enough information in the graph to figure out what that is. Well, f of 3 is, do we know what f of 3 is? I suspect we have enough. Oh, I know what's going on here. We don't need to know that, do we? Because what's f prime of 3? It's 0. So this is, that whole first term is 0. So we actually didn't need to look at that. So just the 0 here does it for us. And minus f of 1, that was the one they gave us. That's e squared. And f prime of 1, well, this is the f prime function, so that's negative 4 all over 2. So that's negative, negative, that's 4e squared over 2, or 2e squared.